Electrostatics, 4-point charges plus Q, minus Q and minus Q are placed on the corners of a square upside to L. The electric potential at a point A midway between the two charges plus Q and minus Q is given by. So here, this is a square and one charge is here plus Q, another charge is here plus Q, then this charge is minus Q, this charge is minus Q. Now, suppose this is point A, which is midway. We have to find out total potential. So we join this and this. Since side length is 2L, so this will be L, this will be L, and this. Suppose this is X, this will also be X. So first of all, we have to get X. So X can be obtained by using Pythagoras theorem. So 2L, so it will be root 4L square plus L square, that is L root I. Now potential at point A will be Q divided by 4 pi epsilon naught L due to this charge, then Q divided by 4 pi epsilon naught L due to this charge. Now due to this charge, it will be minus Q divided by 4 pi epsilon naught L root 5, and due to this charge, it will also be same, minus Q divided by 4 pi epsilon naught L root 5. Now we can take common Q upon 4 pi epsilon naught L. So we will get 1 plus 1 minus 2 upon minus 1 upon root 5 minus 1 upon root 5. So that will be equal to 2Q divided by 4 pi epsilon naught L times 1 minus 1 upon root 5 volt. So this is our answer. Now let's go to next question. The electric potential at a point in free space due to charge Q coulomb is Q times 10 power 11 volt. The electric field at that point is. So V is given by Q upon 4 pi epsilon naught R, and electric field is given by Q divided by 4 pi epsilon naught R square. If we square it, so V square equal to Q square divided by 4 pi epsilon naught R whole square. That can be written as Q times Q divided by 4 pi epsilon naught times 4 pi epsilon naught R square. In place of this term, we can write E. So we get V square equals Q divided by 4 pi epsilon naught times E. Our purpose is to get E. So our purpose is to get E. So E will be equal to V square times 4 pi epsilon naught divided by Q. So V square, in our question it is given Q into 10 power 11. So Q square into 10 to the power 22 into 4 pi epsilon naught divided by Q equal to E. So 1 Q will cancel out and our answer will be Q times 4 pi epsilon naught times 10 power 22 volt per meter. Now let's see next question. 4-point charges minus Q minus capital Q minus small q 2Q plus 2Q are placed at each corners of a square upside length A, the relation between Q and Q for which the potential at the center will be 0. Suppose this is a square whose side is A and charges as minus Q, 2Q, and 2Q. Center will be equidistant from each corner. So we assume it to be x, although it will be a upon root 2, but let's take it x, x, x. Now we find potential at this point. So V will be equal to minus q upon 4 pi epsilon naught x plus 2q upon 4 pi epsilon dot x minus q upon 4 pi epsilon naught x plus 2q upon 4 pi epsilon naught x. But potential is 0, so we put it equal to 0. So we get q plus small q equal to 0, from where q equal to minus q. Now let's go to next question. In a region, the potential is represented by V, which is function of x by z, 6x minus 8xy plus 6yz, where V is in volt and xyz are in meters. The electric force experienced by a charge of 2 coulomb situated at point 111 is. So here we are given V equals 6x minus 8xy plus 6yz. So we find electric field. Electric field is given by Ex I cap plus Ey j cap plus Ez k cap. And Ex is minus dB upon dx I cap minus dB upon dy j cap minus dB upon dz k cap. Now we try to get the value of dB upon dx, dB upon dy, and dB upon dz. So from here, dB upon dx. So x will be assumed to be variable and others will be constant. So we will get 6 minus 8y, and here x, y, z are given 1, 1, 1. So it will give minus 2. Similarly, dB upon dy. So y will be variable, others will be constant. So first term will be 0 minus 8x plus 6z. And when we put 1, 1, so we get minus 2. Similarly, dB upon dz will be equal to. So here z will be variable and other things will be constant. So these terms will become 0. Only 6y will be left. So, and y equal to 1. So we will get 6. Now we can get electric field by putting the values. Minus dB upon dx is minus 2. So 2i plus 2j minus 6k. Now modulus of electric field will be equal to square root of 4 plus 4 plus 36, which is root 44. And we know that F equal to QE. So here Q is given as 2 coulomb in the question here. So 2 times root 44. 2 we can take common, so it will be 4 root 11 Newton, which is our answer. Now let's see next question. The potential involved in a region is expressed as V is function of x by z as 6xy minus y plus 2yz. Then electric field at point 110 is given by. So let's see the solution. Same rule. E will be equal to Ex I cap plus Ey j cap plus Ez k cap. and Ex will be minus dV upon dx. So here V is given as 6xy minus y plus 2yz. So when we differentiate it with respect to x, other things are assumed to be constants. So second and third term will become 0. Only we will get 6y, and y is given as 1. So it will become 6. Similarly, ey, which is minus dv upon, here minus sign is left, so it will become minus 6. dv upon dy, that is minus sign outside, and then we differentiate it with respect to y. So this will give 6x. Second term will give minus 1. Third term will give 2z. Here we are given x equal to 1, y equal to 1, and z equal to 0. So when x equal to 1 we place here, so we will get 5. Hence we get minus 5. Now Ez, which is minus dv upon dz. So minus of, when we differentiate it with respect to z, only 2y we will get. So y is given as 1, so we will get minus 2. Hence electric field will be Ex minus 6 I cap plus Ey is minus 5 j cap plus Ez minus 2 k cap, which is our answer. Now let's take next question. The electric field in a certain region is acting radially outward and is given by E equal to AR. A charge contained in a sphere of radius A centered at the origin of the field will be given by. So here we are given a sphere whose radius is A, charge is Q. So electric field at the surface will be given by Q divided by 4 pi epsilon naught A square. And here we are given electric field as A into R. Here R is distance. So at the surface it will be A. So E will be capital A small a. Both E must be equal. So we write Q divided by 4 pi epsilon naught A square is equal to capital A small a. Our concern is to get small q. So Q will be equal to A times 4 pi epsilon naught AQ, which is our answer. Thank you for watching.